So power set, as we discussed in the last class, it's a collection of all subsets of a given set. When a set is given, non-empty set is given, then all possible subsets of the given set we have to collect, and which is to be expressed within second bracket. So it's a set of subsets. So its elements are in the set form in case of power set, and number of elements of a power set is given by 2 to the power n, where n is the number of elements of a given set. If A is any set and number of elements of A is 2, then number of elements of power set of A will be 2 to the power n, that is 2 to the power 2. So that is 4. So we discussed this much about power set examples, number of elements in the power set, some examples in the last class. So now universal set. Universal set is just when you consider few sets uh, in a particular context, then the biggest set considered in the discussion, considered in a particular context, the biggest one is anticipated as universal set. Suppose there are some sets on numbers, like set of natural numbers, set of rational numbers, set of even numbers, set of odd numbers, set of integers, set of whole numbers, set of real numbers, set of complex numbers. These are sets. So if we consider a particular context among these sets, then if we observe, the biggest set is complex numbers. So if we avoid complex, then up to real numbers, so R is the biggest one. That means integers subset of real numbers, set of natural number is subset of real number, set of rational number subset of real number, set of even numbers subset of real numbers. So all the sets are lying inside the biggest set, superset, that is set of real numbers. So then we will say the set of real numbers is universal set. And suppose few examples of sets we considered. A consists of few elements. B another set consists of other few elements. C another set which is consisting so many elements. So here, if suppose C is the set which consists all the elements from A and B. So in these three examples, A, B, C. So C is the superset. So A and B are contained in C. That means all the elements of A and all the elements of B are lying inside the set C. So C is the superset. So whatever situation, whatever discuss we make on the elements, behavior of elements, or whatever about these three sets, in this context, C is the superset. So C is the universal set. It is just a consideration. So among some sets, the biggest one is considered as universal set. So let's pick up some examples from an exercise. I do hope you have understood about the previous discussion on subset, power set, subset, power set, and universal set. And based on this previous discussion, some examples given here in the exercise. Let's pick up some examples, some questions. Look at the screen. Question number one. Some sets are given. Some are in set builder form. Some are in roster form. So look at sub question one. Here we have to use the symbol subset or not subset. First set is the subset of the second set or not. Just to observe that one. And number 1, 2, 3, 4. The first set consists of 3 elements 2, 3, 4. Second set consists of 1, 2, 3, 4, 5. So very clearly, the elements of the first set are belonging to the second set. So obviously subset. So subset symbol will be here. So this is the symbol of subset, and this is not subset. Simply not subset. First set is not subset of the second. And number 2, ABC. First set ABC, and the second set BCD. So here obviously not subset, because ABC elements are not belonging to in the second set. Two elements are there obviously, B and C, but A is there in the first set, but A is not in the second set. So clearly we cannot say all the elements of first set are belonging to the second set. We cannot say. So that's why not subset here. And next one, number 3, X is a student of class 11 of your school, and X is a student of your school. So it is obviously a subset, because in the second set, all students. Second set, collection of all students of school. And in the first set, only the collection of the 11th standard students. So this is obviously subset. And 4, if you observe here, X is a circle in the plane, and second set X is a circle in the same plane with radius 1 unit. You know, first set X is a circle in the plane. That means all possible circle on a plane you consider are there in the first set. All types of circles. But in the second set, only those circles are there whose radius is 1 unit. Whose radius is 1 unit. So obviously, second set is consisting only a particular type of circles having 1 unit radius. So definitely it cannot be subset, because all circles are not lying in the second set, which is circles of radius 1 unit only. And next one, X is a triangle in a plane. X is a triangle in a plane means all triangles, all types of triangles, all possible triangles with different measures, all possible triangles. And in the second one, X is a rectangle in a plane. So it is not subset, because elements of the first set are different with the elements of the second set. No one element of the first belonging to the second. So obviously not subset. X is an equilateral triangle in a plane. And next, X is a triangle in semi. So this is subset, because X is an equilateral triangle. So in the first set, only those triangles are there which are equilateral. And in the second set, collection of all possible triangles. So in all possible triangles, definitely equilateral triangles are also lying here in this collection, because this is after all second set, after all collection of all possible triangles. So obviously it is subset. Substitution 6. So it is subset. And number 7, X is an even natural number. Even natural number like 2, 4, 6, 8, 10, so on. X is an integer. You know, in the second set, all integers are there. Positive integer, negative integer, 0. It's a huge set which comprises all integers. And in the first set, only even natural numbers. So even natural numbers are integer. So that means all the elements of the first set are belonging to the second set. So obviously it is subset. Let's go to another type of examples. So examine whether the following statements are true or false. So here some relations are given between two sets which are related to subset and belongingness. Just to observe whether statement is correct or not. And the first one, if you see A comma B, not subset of BCA, so it's false. And in the next one, A comma E, subset X such that X is a vowel of the English alphabet. Very, very clearly it's true because these are vowels and which are comprising in the second set, right hand set. Number 3, 1, 1, 2, 3, and 1, 3, 5. It's false because all are not lying here. And in the next four, A, it's a set comprises only one element, A. And here it is A, B, C, this subset. Yeah, absolutely right. So it's true. And 5, A set which comprises an element A belongs to A, B, C. It's false. It's actually a wrong representation because this is a set itself, and again this is a set itself. So between two sets, we can say only subset or not subset, subset or not subset. So this A within second bracket, it's called singleton set, having single element. So this singleton set is not belonging to this set, but from this set the element only A belongs to this set. So it is, after all, in presence of second bracket, it is a set. So as a whole, this set is not lying inside this set, but yeah, its element is belonging to this. So this is set, this is set. So set between two sets, we have to observe whether set is first set is subset of the second set or not. So this symbol does not exist here. In absence of second bracket of the first set, it would have been correct, it would have been true. But due to presence of the second bracket, it becomes set. So this set does not is not contained in the second set. But if subset symbol is placed here, then it would be correct. So wrong representation it is quite, because belong epsilon sign does not exist here. And in the next one, if you see here, x is an even natural number less than 6, even natural number less than 6. The subset of x is a natural number which divides 36. Divides 36. That is all factors of 36. And even natural numbers less than 6. Even natural number less than 6 means 2 and 4. 2 and 4. And 2 and 4 obviously factors of 36. So very clearly it's true subset. And again in the next type, based on similar concept, which of the following statements are incorrect and why? Here a set is given A, which consists of 1, 2, again within second bracket 3, 4, then 5. If you observe this set, it's a collection of some elements, that is elements are 1 2 5, it's okay, but another it's a different type of element is included here, that is in set form 3 comma 4. this is as a whole this is as a whole is present here as an element, but it is itself a set because the elements are expressed within second bracket. So it is the third element. So first element 1, second element 2, third element 3, 4 is set as a whole, third element. Fourth element is 5. This third element itself is set because within second bracket it is in set form expressed. So in case of this set, this third element belongs to this set. Third element is not subset of A. So from this given set, we can observe it carefully. So in the sub one, 3, 4, 3 comma 4 as subset of A. It is false. It is not correct because 3 comma 4 within second bracket, this as a whole is present inside A as an element. So since this is an element of A, so the belongs to sign will be here. Epsilon will be here. This sign. So subsets symbol does not exist here. So belongs to. So 3 4 as an element is present in A. So belongs to. The sign will be here. Epsilon sign will be here. Not subset. Number 2, 3 comma 4 is the third element of the given set A belongs to A. Yeah, it is absolutely. It's correct. 3 comma 4 within second bracket belongs to A. This is absolutely correct because this is present in A as an element. An element always belongs to a set. Element cannot be a subset of a set. Element belongs to a set or does not belong to a set, but element cannot be subset of a set. Third one. Here it is, 3, 4 within second bracket itself, it's an element of the set. But on this element, if we place second bracket here, now it is a set. Now it is set. So since it is set, we can observe whether this set subset of A or not. And obviously, this is an element of 3, 4 within second bracket. This is an element of the set A. When we place the second bracket on it, then definitely it becomes a set. And this set we can now say whether it is subset of A or not. Yeah, obviously it is subset of A. One belongs to number 4. One belongs to A. Yeah, true. One is element of A, so one belongs to A. One subset of A is false because one is an element of A. So an element cannot be subset of a set. And one element may or may not belongs to a particular set. So one belongs to A, one is not subset of A. If we put second bracket here, then it will be correct. So this is an element. So element cannot be subset of a particular set. So to be subset or to place the subset symbol, both must be set. So first one is also set, second one is also set. Then we can compare whether first one is subset of the second one or not. Both must be set. So here left hand side one it's an element and right hand side it's a set. So element cannot be subset of a particular set. Similarly 6. 1 comma 2 comma 5 within second bracket 1 2 5, yeah, 1 lies in A, 2 lies in A, and 5 itself lies in A. So all the elements are belonging to set A. So very clearly we can say subset of A. And the next one, if you see 1, 2, 5, 1, 2, 5, yeah, all the elements are belonging to the set A, and in second bracket, so it's obviously subset because all the elements of the set are belonging to the set A. So it is obviously subset. So it belongs to sign, so epsilon is given here, so it's false. 1, 2, 3, subset of A, subposition 8. 1, 2, 3, subset of A, it's false. Because 1 is there in A, no problem. 2 is an element of A, no problem. But 3 is not element of A. 3 does not belong to A. 3, 4 combinedly, 3, 4 combinedly as a set present in A. So only 3 as an element not present in A. So this cannot be subset of A because 1 and 2 are belonging to A, no doubt, but 3 does not belong to A. So it is not subset. So it's a subset given, so it's false. 5 belongs to A, false, because 5 is a set itself. So we have to observe it is this set subset of A or not, not belongingness. And number 10, if you say phi subset of A, yeah, it's true. Phi is itself a set which represents empty set, null set, or void set having no elements. So it's always a subset of any set. And number 11, phi within second bracket. Phi within second bracket subset of A. Phi as a symbol which represents a particular type of set, that is null set. So if we put a second bracket here, it is representing a new set. Within second bracket, a symbol is written, so it's new set, which consists of one element, that is phi. In presence of second bracket, it is not empty set. In presence of second bracket, it is a set which has one element, and the element is phi itself as a symbol is present. So if we put second bracket, it is set. It is not empty set. It is a set having single element. It is phi itself as a symbol. Now this is subset of E. It is false because phi as a symbol is not present as an element in A. Phi as a symbol is not present in A as an element. So it is not subset of A. But in the previous example, that is 10, phi is subset of A. It is true because phi, this is standardized representation of null set. This null set is always subset of any set. But if we put second bracket here, it is not representing at all null set or empty set of phi. So when second bracket is placed, and in between second bracket, inside the second bracket, whatever you write, it may be alphabets, it may be symbols, it may be numbers, whatever you write, automatically it will be giving us new set where the elements will be what you write inside the second bracket. So it's actually not empty set, null set, or void set. It is a singleton set. That is set having single element. So it is not subset of A. It's wrong representation. So this much about it was concept of subset, and when a set is said to be subset of another set, only based on this concept. This much examples are given here. And I do hope you have understood, and symbolically now you do not have, I think, any confusion. It is just a matter of understanding, matter of experiencing about this language of sets, because subset belongingness or belongs to the superset and empty set, null set. So this symbolic concept you should have. Otherwise, you cannot go through any particular uh, script. So this is very much fundamental and very much important to understand this, because when you go through any scripts on set theory, then to understand language of sets, you must understand, you must experience all these fundamental concepts. So I do hope you have understood nicely about this concept of subset and regarding its expression mathematically or symbolically. And based on the power set, one example is given in question number 4. And write down all the subsets of the following sets. Already discussed the last class how to write the subsets of power set. So you can write yourself. Very simple. First one, if you say only one element is there, A. So its subset will be always null set is a subset of any set. So one subset of this set is phi, another is A itself. So only two subsets are here, and here two elements are here. So number of subsets will be 2 to the power 2, that is 4. One is 5, another is A itself, third one is B itself, and fourth one is AB itself. AB itself. So 4, total 4 subsets will be here. And here three elements. Three elements are there in this set. So number of subsets, that is number of elements of its power set, will be 2 to the power n. That means 2 to the power 3. Three elements are here, so 2 to the power 3. Formula is 2 to the power n. N is the number of elements of the set A. So it is 3, n is 3, so 2 to the power 3. 2 to the power 3 means 8. So 8 subsets will be here. So like taking one alone, one subset, taking two alone, another set, taking three alone, this third set, taking 1, 2, fourth set, taking 2, 3, fifth set, taking 1, 3, sixth set, taking all this is 7 and 5. 8. So total 8 subsets you can write those. And phi 1 itself, it's a null set, no element is here. So phi is the subset of itself phi. So how many elements of has if A equal to 5? So obviously 0, 2 to the power 0 is 1, so it's 1. So A is 5, 5 means number of elements is 0. If number of elements is 0, then as per the formula 2 to the power n, that means 2 to the power 0. 2 to the power 0 means 1, so it's only 1, and that is 5 itself. So I think you have understood whatever we discussed on the subsets and the power sets, and on some intervals. Few questions are there in this exercise, and which I'll discuss later on in the next class. That uh, you can go through this exercise, as I told you earlier, that for fundamental concept of set, this book you can buy, and you can go through this book and you can prepare yourself. So thank you so much.